Hello everybody. Today in these videos we will be discussing about hydrocarbons. First of all, what's hydrocarbon? As the name itself suggests, hydro and carbon, right? Hydro means hydrogen, carbon is this carbon. So basically this is something related to carbon and hydrogen bonds. Fine. So moving ahead, these hydrocarbons have further classification depending upon the bond between the two carbon atoms. Fine. And these classifications are saturated hydrocarbons, unsaturated hydrocarbons, and aromatic hydrocarbons. Now let us see what are these individually. So saturated hydrocarbons, when different carbon atoms are joined together so that they have single bonds between two carbon atoms, that is carbon-carbon single bond and carbon-hydrogen single bond, we call them saturated hydrocarbons. And these, when different carbon atoms are joined together in the form of an open chain, and there is single bond between them, we call them alkanes. And similarly, if all these carbon atoms are joined together in the form of a closed chain, fine, in the form of a ring, we call them cycloalkanes. Fine. Now talking about unsaturated hydrocarbons. In case of unsaturated hydrocarbons, different carbon atoms are joined together, but there is no single bond between them. They have multiple bonds. They may have double bonds, or they may have triple bonds, that is carbon-carbon double bond, or they may have both. In the same compound may have carbon-carbon double bond and carbon-carbon triple bond as well. So these are all unsaturated hydrocarbons. And then comes aromatic hydrocarbons. Aromatic hydrocarbons are also cyclic hydrocarbons, but they are of special type. Fine, this is just a general introduction of all these three types of hydrocarbons. Now we will be studying about all these in detail in this chapter. Fine. So now let's discuss about alkanes. First of all, these hydrocarbons are not reactive under normal conditions, that is they're inert under normal conditions, and they do not react with acids or bases or any other reagents, and hence they were earlier called as paraffins. Fine. So now what are alkanes and how do you derive them? In case, consider methane, that is the first member of alkane group. Methane, that is nothing but C carbon atom bonding to 4 different hydrogen atoms, hence CH4. Fine. Now what you do is, you replace one of these hydrogen with another CH3 molecule. Fine. So it will be CH3 plus CH3. So the compound will have 2 carbons and 6 hydrogens, right? So this compound, that is the formula C2H6, is called ethane. Ethane is derived from methane. Fine. Now, if you remove one of the hydrogens of ethane and add one more CH3 to it, it will become C3 and H8, right? So we call it as propane. And now let us discuss about the general formula for alkenes. All alkanes, the formula of all alkanes can be written generally as CnH2n plus 2. For example, in case of propane, propane has 3 carbons, right? It is C3 and H will be H2n plus 2. 3 into 2 is 6 plus 2 is 8. So propane will have C3H8. Fine. Now we'll discuss about the preparation of alkanes, like how are alkenes prepared, what are the different methods to prepare alkanes. Fine. You know petroleum, right? Petroleum and natural gas, these are the main sources of alkanes. So now moving ahead, talking about the preparation, the first method is the preparation of alkanes from unsaturated hydrocarbon. We know that alkanes are saturated hydrocarbons, right? When we talk about unsaturated hydrocarbon, if there is a double bond between 2 carbon atoms, we call them alkenes. And if there is triple bond between 2 carbon atoms, we call them alkynes. Fine? Fine. So we'll see how to prepare these alkanes from alkenes and alkynes. And this method is known as hydrogenation. So what happens is, when dihydrogen gas reacts with unsaturated hydrocarbon in the presence of some catalyst like platinum or palladium or nickel catalyst, alkanes are formed. So what basically happens is, this dihydrogen gas is absorbed by the catalyst on the surface, and this activates the hydrogen-hydrogen bond, and hence this leads to the formation of alkanes from unsaturated hydrocarbons. For example, if you want to prepare ethane, what we do is we take ethene molecule, the compound ethene, and react it with dihydrogen in the presence of platinum, palladium or nickel, and we get ethane. And you should also know that in case of platinum and palladium catalyst, this reaction takes place at room temperature. Fine. But in case of nickel catalyst, when nickel acts as a catalyst, it requires a little higher temperature for the reaction to proceed. Fine. Another example is you take propene, and then when dihydrogen reacts with propene in the presence of platinum or palladium or nickel catalyst, we get propane. Fine. This is about the first method of preparation of alkenes. Next is the presence of alkanes from alkyl halides. Alkyl halides. Halide is nothing but halogens, chlorine, bromine, fluorine, right? So in this method, alkyl fluoride is an exception. Fine. So when alkyl halides undergo some reactions, they form alkanes as well. So the first method, what happens is when these alkyl halides on reduction with zinc and dilute HCl gives alkanes. Fine. For example, consider one alkyl halides, like the simple one is CH3Cl, that is chloromethane, right? On presence of dihydrogen in the presence of zinc and dilute HCl will give methane, CH4. Fine. Now there is one more method. When we talk about alkyl halides, there is one more method for the preparation of alkanes from alkyl halides. And this method is called Wurtz reaction. And basically this reaction is used for the preparation of higher alkanes having even number of carbon atoms. Higher alkanes means it will have more number of carbon atoms. Fine. So in this reaction, what happens is alkyl halides react with sodium metal in the presence of dry ethereal and they form alkanes. Fine. For example, bromomethane reacts with sodium metal in the presence of dry ether to give a compound ethane. And similarly, bromoethane reacts with sodium metal in the presence of dry ether to give a compound butane. So the next method is the preparation of alkanes from carboxylic acid. So even in this method, there are two methods to prepare alkanes from carboxylic acid. Fine. The first one is using sodium salt of carboxylic acid. So carboxylic acid is represented by COOH, right? So sodium salt of carboxylic acid is nothing but replacement of hydrogen by a sodium ion. Fine. So that will be COONA. Fine. So when this sodium salt of carboxylic acid reacts with a mixture, is heated, when the sodium salt of carboxylic acid is heated with a mixture of soda lime. What is soda lime? Soda lime is a mixture of sodium hydroxide and calcium oxide. That is a mixture of NaOH and CaO. So now when the sodium salt of carboxylic acid is heated with a mixture of soda lime, we get alkanes. And basically the alkane obtained will have carbon atoms one less than the carboxylic acid. Fine. So the alkanes, the number of carbon atoms in the alkane obtained will be one less than the number of carbon atoms in the carboxylic acid, and hence this is called as decarboxylation. Fine. So the next method is called this electrolysis method. In this method, an aqueous solution of either sodium or potassium salt of carboxylic acid, that is either COONA or COOK, on electrolysis gives alkanes, and these alkanes have even number of carbon atoms at anode. So when we talk about electrolysis, there will be anode and cathode as well, right? And now this is how the reaction proceeds. Properties of alkanes. First we'll discuss about the physical properties. Fine. So we know that these alkanes are non-polar, right? And this is because of the covalent nature between the carbon, hydrogen and the carbon-carbon bonds. Yes, right? And this is due to the less electronegative differences between the carbon and the hydrogen atoms. Fine. And then these alkanes have very weak van der Waals forces of attraction. And because of that, the alkanes having the carbon atoms from 1 to 4 the number of carbon atoms, that is 1 carbon to 4 carbons, they're all usually gases. Fine. And then when the alkanes have the number of carbon atoms from C5 to carbon atom 17, they're all liquids. And carbon atoms 18 onwards, they're all solids at room temperature. Fine. And these alkanes are colorless and they're odorless as well. And since they're non-polar, they're hydrophobic. That is, they're not dissolved. They can't be dissolved in water. So usually it is like non-polar substances dissolve in non-polar solvents and polar substances dissolve in polar solvents. It's basically like dissolves in like. Fine. And the boiling point of the alkane increases as the molecular masses of the alkanes increases. In simple words, as the number of carbon atoms of the alkanes increases, that is methane, ethane, propane and so on, as the number of carbon chain increases, the boiling point also increases. Next, we'll discuss about chemical properties. Fine. So first, we'll discuss about the substitution reactions. What do you mean by substitution? Substitute. There is something else in some place, right? And something else comes and replaces it. So this is going to substitute the place of whatever was present here, right? So when we talk about reactions, so what happens is one or more hydrogen atoms of these alkanes are replaced by substituents like halogens or nitro groups or sulfonic acid groups. So when we talk about halogenation, it usually happens at a higher temperature, like more than 200 degrees centigrade or something like that. And it can also happen in the presence of diffuse sunlight or ultraviolet light. Fine. But when we talk about nitration and sulfonation, these are not shown by the lower alkanes. They do not undergo these two reactions. So the reactions in which the hydrogens of alkanes are substituted are called substitution reactions. Fine. For example, if we talk about halogenations, consider what you need is alkanes, right? So you have CH4 and you react it with any fluorine, any halogen, that is chlorine or anything. So what will you get? Alkyl chloride, right? When you react it with chlorine, you will get alkyl chloride. CH4 plus Cl2 gives CH4, CH3Cl, fine? That is methyl chloride, right? And how? And now the reactivity rate of this is the tertiary alkanes are more reactive than the secondary alkanes, and the rate, that is the rate of reaction, and secondary alkanes is more than the primary alkanes. And when we talk about halogens, the rate of substitution is fluorine is more reactive than chlorine, then comes bromine, then comes iodine, that is I2. So fluoride ion is very rigorously reacting. So we can't control the reaction. But when we talk about iodination, it is a very slow process. Fine. So what we do is it requires some oxidizing agents to proceed with the reaction. So we use like HNO3, HiO3 when it comes to iodination. So this halogenation proceeds via free radical mechanism, and there are three different steps involved in this. The first one is called the chain initiation. Second is the chain propagation, and third is the chain termination. So what happens? It initiates, propagates, and then there's a termination. Fine. So in chain initiation, what happens? It's halogenation, right? Let us consider chlorine molecule. Chlorine molecule is nothing but Cl2. There's one Cl and Cl. There's a bond between them. So what happens in this stage is there's a homolysis, that is homolytic cleavage. We discussed about homolytic cleavage, right? What happens in homolytic cleavage? The bond breaks in such a way that both the atoms get one electron each, right? So that is what happens. That is called free radicals, right? So when the chlorine molecule, when the bond is broken by homolytic cleavage, it forms chlorine free radical. Fine. So this Cl-Cl bond can break easily because it's weaker than the CH bond or CC bonds. Fine. So now talking about the chain propagation, this chlorine free radical is unstable, right? So what it does is it attacks the methane. Fine. So now what happens? There's CH bonds in methane, right? There are 4 CH bonds. It breaks one of the CH bonds of methane and forms methyl free radical. And this chlorine free radical, it breaks the bond and takes the reaction in the forward direction. Fine. So now what we have is methane free radical and we have HCl. Fine. Because it breaks the CH bond and it takes away hydrogen, right? So it forms HCl and we have methyl free radical. So now this methyl free radical is again unstable. So what it does it is reacts with another molecule of chlorine, that is Cl2. Fine. So this methyl free radical reacts with another molecule of chlorine and then it gives CH3Cl and one more chlorine free radical. Fine. Next is the chain termination. So what happens is in a reaction, when all the reactants have got consumed, the reaction stops, right? So the chain termination is nothing but the stopping of the reaction, right? So there are three different ways how the reaction stops. So now what happens is we have two chlorine free radicals, right? Cl and Cl. These two combine to form a molecule of chlorine. Fine. Or in case of methyl free radicals, two different methyl free radicals combine to form a molecule of ethane, right? Or in case of one methyl free radical and one chlorine free radical, CH3 and Cl, right? These two combine to form a molecule of to form a compound, that is CH3Cl. That is nothing but methyl chloride, and here the chain terminates. Fine. So this is all about the mechanism of this halogenation. Fine. One is the chain initiation, chain propagation, and the chain termination. Fine. In the initiation, there is a formation of the chlorine free radical. In the propagation, this chlorine free radical attacks the methane molecule, and then it forms methyl free radical, and then it again attacks another molecule of chlorine and forms CH3, Cl, and then HCl. Fine. And in the chain termination, there are three different ways. That is, two chlorine free radicals form one chlorine molecule, or two methyl free radicals form one molecule of ethane, or one chlorine free radical and one methyl free radical gives CH3Cl, and the reaction stops at that point. Fine. Next, let us discuss about the second property, that is combustion. What happens over here is when alkanes are heated in the presence of air or dioxygen, the combustion takes place. What happens is it oxidizes to form carbon dioxide and water, and during this process there is an evolution of enormous amount of heat, and that is why alkenes are used as fuels, because they evolve a lot of heat, right? Fine. The next one is the controlled oxidation. What happens in case of controlled oxidation is there is a limited supply of the oxygen. Fine. So when alkanes are heated with a limited supply of dioxygen under high pressure and with the suitable catalyst, they give variety of compounds. It may be alcohols or aldehydes or even carboxylic acids. Fine. So next is the isomerization. When these alkanes, that is N-alkanes, are heated with anhydrous AlCl3, that is aluminum chloride, and HCl, that is hydrochloric acid, it isomerizes to form branch chains. Fine. So the alkanes, when it is heated with anhydrous AlCl3 and HCl, it isomerizes to form branch chain compounds, and hence it will lead to major product and minor product. Usually minor products are ignored. When we are doing reactions, we consider the major products only, so we report just the major products. Fine. So the next property is aromatization. So what happens is when alkenes having carbon atoms more than 6, fine. So these alkenes having more than 6 carbon atoms in the presence of very high temperature, there's around more than 500 degrees centigrade, in the presence of 10 to 20 atmospheric pressure, and in the presence of catalysts like oxides of vanadium, molybdenum or chromium, what they form is they get cyclized to form benzene or its homologues. So what happens in aromatization when alkenes having more than 6 carbon atoms under very high temperature, that is more than 500 degrees centigrade, that is 773 Kelvin with 10 to 20 atmospheric pressure, in the presence of oxides of vanadium, molybdenum or chromium, they cyclize to form benzene and its homologues. This is called aromatization. Fine. The next is the reaction with steam. So when alkenes, for example, contain methane, consider methane. So when it reacts with steam at very high temperature in the presence of nickel, that is around 1273 Kelvin, in the presence of nickel, it forms carbon monoxide and dihydrogen. This method is used very much for the industrial preparation of dihydrogen. Fine. Next is pyrolysis. What happens in pyrolysis is usually higher alkanes, fine, they are broken down into lower alkanes. So in pyrolysis, when higher alkanes are heated, they decompose into lower alkanes. This decomposition of small fragments from higher alkane in the presence of heat is called pyrolysis. Usually, pyrolysis proceeds by free radical mechanism. Fine. This is all about the chemical properties of alkane. So now we have discussed about all the properties of alkane, that is the physical properties and chemical properties as well. Hello everybody. I hope you are liking this course, and if yes, hit the like button and share it among your friends. And please do subscribe to read my course and check out their other videos as well. There are a lot of interesting videos. And thank you for watching.